Good day, I am Mikel Galdonis and for my final laboratory exercise in data communications and networking too. We have come full circle and all we are gonna do is this network topology. This is all that we need to configure for we have reached the final lesson in the course, which is all about the NAT method or the network address translation. So over here are a list of commands which I have copied on my notepad, on my Microsoft notepad, and I am due to execute them on each of the routers right now. So let's get started. Alright, now that we have configured the open shortest path first protocol on all of our routers, we will enter first the show IP interface brief just to check if all of our ports are up. And as we can see, not all of our ports are up, but the necessary ones, being fast Ethernet 00 and serial 000, are up and running. So that leads us to the next step of our exercise, which is to configure the network address translation. So we are in the main part of our laboratory exercise, and we are going to do the configuration in on router 2. Sorry, on router 2. So we'll type config d, and I will follow these commands over here. Alright, so now that we have configured our network access translation on router 2, it is time to turn on debugging on router 1. So to do that, we will type debug IP ICMP. Now packet debugging is on. So now that we have configured router 1 as well, we now move on to router 3 in order to ping the respective IP router 1, and so we will do just that right now. And while we are pinging the IP address of router 1 and obviously sending packages and determining their success rate, which should be 100%, we are supposed to see this these lines of codes appear in router 1. ICMP echo reply sent, ICMP referring to the Internet Control Message Protocol. And yes, since we are sending 5 data packets to router 1 while pinging, we should also receive 5 responses. So let us do just that right now. And as we can see over here, the success rate is just as expected, 5 out of 5. We also have 5 ICMP replies. And yes, with that, we can now move on to another step in testing our NAT translation. So to do that, we need to debug IP NAT, and we're going to do this on router 2. So first, let me exit that. Write memory to save the configuration, and debug IP NAT. And now our IP NAT debugging is on. So now let us go back to pinging the IP address of router 1, but we will also observe router 2 right now instead of router 1 to see what the response of NAT is. So we need to see what the messages that it will send and hope that they will match the ones written over here. So let us do that. 2.168. Let me bring router 1 up. And as we can see, it sends us the expected messages over here, expiring 192.168.10.2, ICMP 1 all the way to 5, and the rest over here, S is equal to 192.168.5.0, then goes to 192.168.10.2, and this is the destination. And what it's trying to tell us is that the source IP address is the one, letter S over here. It came from this IP address 192.168.5.50.2, and it sent it to 192.168.10.1, and this is where the packet ended up going to. And now that we have that step out of the way, it is time for us to do the final step in our laboratory exercise. And as we can see, we are required to ping once again our router 3, and now we are supposed to like show the result of IP NAT translation when we ping the IP address of router 1. So we will do just that, 2.168.10.1. And as we can see over here, more were added. And if I type in show IP NAT translation like I did, it will show us this table containing the protocol, which is the ICMP, the inside global, which refers to the public IP address assigned to our device or the router for communication with an outside network, which is which can be denoted by this one, the outside local, which is the IP address of the external device as seen by the inside network. And we also have our inside local address, which is the private IP address of the device inside the network before the network address translation. And also we finally have the outside global column of the table, which represents the actual IP address of the external device when it goes into the public domain. And as we can see, we got the same messages that we got from our NAT a while ago, expiring 192.168.10.2, which is our inside global IP address. It just expired, and it was reassigned. It also showed our inside local address in the parentheses with the ICMP 16, 17, 18, 19, and 20. And with that concludes our 10th and final laboratory exercise in data communications and networking too. It's been one roller coaster of a journey where I learned a lot more than I already knew about networking. And with that, I am confident that I will be able to tackle my course project, which will come up in the next video. So, thank you for watching and have a nice day.